webinar. We're excited to be partnering with the Software Guild. We're here with Chief Academic Officer Eric Wise to discuss IT pathways, career options, and guidance. So thank you, Eric, so much for joining us today. If you guys have any questions throughout the webinar, you'll have a little questions panel in that sidebar, and you guys can go ahead and type them, and we can ask them, or if you want to raise your hands, we can go ahead and pause Eric and give you guys audio as well. So a quick few housekeeping items. This session is being recorded, so you guys will get a link to the recording within 24 hours after this presentation so that you can review it. So yeah, feel free to ask questions throughout the webinar, either through the chat box or through the questions as well. And we're also going to have time for questions at the end of this presentation. So Eric, thank you so much for joining us.
Yeah, great.
Yeah, so I'm just going to go ahead and throw the controls over to you if you want to just go ahead and get started.
Yep. All right, so hopefully everybody can see my screen at this point.
Yep, looks good.
All right, good. So I've been working in information technology for a little over 20 years now, because I was doing internships and stuff back in college. So even though I'm not quite 40, I've been working in this field for a long time. And you know, going around and talking to a lot of high school students, talking to a lot of college students, and even adults, it seems like the industry itself has done a very poor job of explaining to people different IT opportunities there are, and more specifically how you get to them. So what I was going to talk about today is IT pathways. You know, I call it career options and guidance, and really all I want to do is walk through the different paths that you can take into the information technology field, what those jobs look like, and more specifically how you can kind of get there. So IT itself is the use of computers to send and receive data. So, you know, what people don't realize is that the information part in information technology is actually literally about information. Every business out there has a database of some kind, has software applications. I mean, even the guy that mows my grass sends electronic invoices, you know, from his payroll system that happens to live in the cloud, but you know, he's using IT. You know, so ever since we first learned, you know, how to write things down back with Hammurabi back in Persia and stuff, you know, we've started cataloging and writing down information. And then, you know, we kind of evolved and we got libraries, and then eventually that led to the Dewey Decimal System. And now we have the internet, you know, and my kids don't even know how to use the Dewey Decimal System anymore. And they have no idea, you know, that we have to, you know, open filing cabinets and stuff at the library and search through index cards to find books. I mean, that's just, you know, that's just Stone Age technology to them at this point. So we're storing more information than ever before. You know, we have all this data. We've got so much data that we've actually got positions now called data scientists whose only job is to mine that data and find trends. So information technology is all about, you know, that process, the storage and retrieval and manipulation of data. So if you're going to get a career in IT, every IT system has the hardware, which is the computer, networking equipment that your systems are running on, and then you have the software applications, which are written to process and transmit the data. So as an IT person, you're going to find, even if you go into something that's software like programming, you are still going to learn a lot about hardware. So I mean, like I've spent a lot of time doing web development. So to become a better web developer, I have learned how databases work. I've learned how the networking stack works, how routers work, how firewalls work. And you know, you're gonna become a jack of all trades just getting into this field. So, you know, what I tell people, you know, if they're interested in IT, almost everybody has a computer these days. step to getting into IT is just mastering your computer, what you're working on. Do you know how to type? Do you know how the file system works? Do you know what the settings in your operating system do? Do you know how to install software? I mean, these are all like basic core competencies that you need, you know, just to get in the door and be able to do the courseware. I mean, the first thing we ask you to do in a lot of our software classes is install the coding tools. So if you don't understand how your hard drive works and you don't understand how to install software, I mean, right out the gate, you're stuck. So the other thing that's both challenging and really fun about IT is the change. Technology changes every year. There's new stuff. I mean, I have literally written lessons for our coding programs that I haven't gotten to teach because the framework the lesson is about will change while I'm creating the lesson. So to be successful, IT is truly a career. We call it lifelong learning. And some people really like that. They like the idea that in 5 years, I will probably be using different tools and different techniques than I'm using today, and I have to learn those. Other people say, wow, that sounds horrible. I would rather learn my skill set once and use it for the next 20, 30 years. That's fine too, you know, but it's just a good thing to note that if you're getting into IT, you're going to be learning forever. It never stops. So when we talk about storage, retrieval, and transmission and manipulation, here are the different specializations that you're going to get into in IT. So you have your network administrators. They're mainly concerned with that storage, retrieval, and transmission. They're very hardware centric. And I'm going to go deeper into each of these categories throughout the presentation. So you know, don't get concerned with the high level overview. Cloud computing is a big thing today. You see the word cloud everywhere. It's a big buzzword. Cloud is not special. Your company had servers somewhere in the building, in a closet somewhere, in a server room. Cloud just means that those servers are now hosted at Microsoft's data center. They're at Google's data center. You're not hosting them physically on site anymore. They're at somebody else's facility. But they're still servers, they're still routers, they're still databases. It's the same basic concepts. It's just the location of the physical hardware has changed. Database administrators, mostly storage, retrieval, and manipulation because they do reporting. So all of your data, your payroll records, your invoices, your customer records, you know, your sales queues. I've done a lot of work in the insurance industry, so policy information, claims information. All of that data has to go somewhere. And it has to go where it can be stored, it can be searched, and it can be reported on. That's what database administrators are basically concerned with, is the actual data itself. And even more importantly, protecting that data. Because nobody's happy when you get the wrong bill or you get the wrong invoice, or you know, if a company's making financial decisions on a report that doesn't have the correct financial information on it. You can really, you know, collapse a business if your data isn't safe and your data isn't correct. So database administrators are very concerned with that. Then we've got the cybersecurity. They're a more specialized branch of network administration. And we have heard a lot over the last couple of years about cybersecurity. There's big hacks, breaches, personal information. You know, the US election apparently had some cybersecurity issues. So, you know, this is cybersecurity of any of these topics is probably the hottest job topic right now. Software development is still very in demand, and we still need a lot of software developers, but cybersecurity in particular is very hot right now. And it's very common, I can tell you through my 20 years of IT experience, that each of these functions will have peaks and valleys. So we'll go through cycles where, like right now, cybersecurity is very hot, and you know, there's not as much need for network administrators. But in 10 years, that'll flip. Architecture, this is my favorite. This is what I did before I ran off and started the Software Guild. Architects they're a jack of all trades. The architect has to look at a system as a whole. So when I'm building that multi-million-dollar insurance system, it is a mixture of software needs, hardware needs, security needs, and architects, just like the architect of a house, has to be able to put all these different functions together, the electricians, the plumbers, the design, and they have to, be able to build this house and make all the pieces work together. Then you have your software developers. They're basically writing code, and most business applications the code is focused on pulling data out of your database, manipulating it, and putting it back. So whether it's Twitter or Facebook, I mean, what are you really doing on Facebook? You're typing in some data, it's being stored in the Facebook data storage, and then your friends can retrieve it. And then you have your data scientists. They're mostly concerned about manipulation. So I have a large landfill mass of information, and I'm going to go in there and I'm going to look for patterns that aren't readily apparent. So if you want to be a data scientist, you're looking at a lot of statistical knowledge, trend analysis, machine learning kind of falls in there a little bit, but you have to be really, really good at math and really good at statistics and really good at intuition. There's a lot more IT functions besides those. So you also have your project managers, that make sure everybody get their work done on time and manage the scheduling and the budget. You've got business analysts. This is one of my favorite roles. If you actually don't want to write code, but you want to decide what the code should do, then business analyst is for you. So a business analyst, usually they're the bridge between the information technology workers and the business. And they kind of talk to both parties and they figure out what needs to be done. They document specs, they document tests, and it's a lot of communication skills. Quality assurance, they check to make sure everything is working properly. And then you have your graphic designers and UI UX because, people are using software. And if you're like me and you're a technical guy, I have no artistic ability whatsoever. So I always leaned on my UI UX people to make my applications look nice and behave nice. So that's a whole thing. If you're more artistically minded, you can be technical and work on a technical team by making applications more usable. And then of course you have your tech support. That's your help desk, answering people's questions, filing bugs with the developer team, and just helping people use your applications. So a lot of different ways you can go. And the interesting thing about IT is that just because you start in network administration doesn't mean you end up there. A lot of people, if you start with network administration, I've seen a lot of network administrators because they set up database servers, they'll actually end up becoming DBAs. Or they'll get more focused on the security side and they'll become a security person, or they'll become a technical project manager because they discover working on their networks that they're really good at keeping track of things. So, you can kind of bounce around and do a lot of roles in IT throughout your career. So it really never gets stale. And then don't forget the engineers and researchers. So, other specializations that are cropping up today, you got robotics, you got AI, and then you've got the people that actually make the computer hardware, the physical hardware. They're designing circuits for Intel and AMD and those. These ones in particular, I just want to make a note that if you want to get into one of these fields, you need to go to college, because the PhD people at the colleges, they're the ones that are on the cutting edge of artificial intelligence, robotics, and all that. So you need to be in a college CS program if you're really serious about those fields. So let's back up now and we'll talk about the difference and give you a little more detail on what they do. So these network administrators, they're really involved in installation and support and management of your network hardware and software. So they're very concerned with reliability, performance, and security. So at your company, you show up in the morning, you type in your username and password into your computer, it fires that off to a network server that manages all the usernames and passwords for the whole company. The network administrators are the ones that set all that up. They're the ones that reset your password when you forget it. They're the ones that install the printers and make sure the printers are working, and they set up the wireless networks and configure the security. So, we used to joke that if you have a good network administration team at your company, you don't know who they are, because every day you show up for work and your stuff just works. and you never have to file a complaint, and you never have to talk to anybody, because all your computer technology is just working, and it's working the way it should be. So that's kind of our joke. If you're a great network administrator, nobody knows your name. If you want to become a network administrator, usually you will specialize with certain vendors. There are certifications from Cisco and Microsoft and IBM and Oracle and vendors like that. And you can go through very quick classes at training organizations. I'm sure that Oregon State has some of them. And you can sit for a test to get your vendor certification. Employers typically value those certifications. So, like I just said, education requirements. Usually you'll get a tech degree from a university. It may not be a computer science degree. It may be an information systems degree in the College of Business. This is one that can be self-taught. There are a lot of people that become network administrators just because they tinker with their computers on their home network. Because you can buy a router for your house, and you can buy switches, and you can buy laptops and desktops, and you can go pretty far installing your own hardware, installing your own software, configuring your home network, and you can get pretty far. If you are self-taught and you want to be a network administrator, you usually start in a tech support role. So you start playing at home, you learn some things, you might even take a certification test or two, but then you usually go work in tech support, and then from there, if you show aptitude, you'll start getting more responsibilities working with the servers and things like that. And eventually you become a network administrator and run all of them. I mentioned before that network administration tends to be a pathway towards database administration, cybersecurity, or cloud administration. So if you want to end up in one of those fields, network administrator is a good place. And you will definitely be on the vendor certification treadmill. Cisco, CompTIA, Microsoft, they all have those certification tests that you're going to want to sit for. And then because the technology changes every few years, like every 5 to 7 years, you're going to want to go renew those certificates to the latest version of those vendor certifications. So cloud computing, like I said, this cloud thing, it's very avant-garde right now. It's very trendy. But all it is instead of having a network administrator physically in your building, setting up computers in your building, you are renting them from Google or Microsoft. Companies like it because it can be more cost effective. It's important to note that it's not more cost effective if you don't have a good plan. So before your company just moves everything into the cloud, you want to do cost benefit analyses. Depending on what you're doing, it is not always cheaper to do it. Some people, the advertising likes to say that it's always cheaper, but I can tell you from experience, it's not. Your seasoned network administrators, they're the ones that usually jump onto the cloud platform, and they tend to work for those cloud platforms, Microsoft Azure, Amazon Web Services, Google Cloud Platform. They are insatiable about hiring cloud administrators. You also still need a network administrator in your company, even if you do go to the cloud, because most of those cloud tools, they have to be configured and managed by somebody at your company. So just because cloud computing is a thing doesn't mean you're firing all your network administrators. You might only need 5 instead of 10, but you still need people that know how to configure those servers. Then we have database administrators. This was my favorite part. I mean, even though I was an architect, I did a lot of stuff. Database administration is near and dear to my heart. So they organize and manage all the data. So I like to say that data is the lifeblood of a business. If an insurance company loses its policy information or loses its claims information, they are screwed. So database administrators are basically the guardians of all the data, and they also get to decide, because not only do you want your data to be safe, you want to be able to get to it quickly. So database administrators spend a lot of time looking at the types of data coming in, how it's being used, how to keep track of it, and they design structures that ensure that accessibility, performance, reliability, accuracy, security. And it's a very high pressure role. I mean, I'm not going to lie to you. If the data gets damaged, you're going to get fired. I mean, it is that serious. I mean, companies need this data. So it's definitely high pressure, but DBAs get paid a lot of money. If you are a good DBA, you will make more money than a programmer. I can tell you that right now, because software developer jobs are getting, you know, they get a lot of attention right now because they're in demand, and there are good salaries there. But I can tell you that DBAs get higher compensation if they're good. If you want to become a DBA, you usually start by learning SQL. So DBAs, even though they understand hardware because they're building their servers, they also dabble in programming because they have to use the SQL language to manipulate their data. So a DBA is kind of a network administrator, software developer hybrid role. If you want to become a DBA, it's actually not something, almost no college I've ever heard of has a degree in database administration. I don't think it exists. Most DBAs become DBAs because they're in a network administration role or they're in a software developer role, and they discover a passion for it. Or, you know, in my case, the DBA, I was a developer, and the DBA at my company quit, and I happened to be the best one at SQL on my team, so they came and said, congratulations, you're the DBA now. And it's very common, and I put a picture of a book up here. This is a real book, A Guide for the Accidental DBA. And that's what a lot of database administrators are, accidental DBAs, where somebody quits, and then you are forced to become the DBA. So it's a stressful career path because you just kind of get thrown into the pool, but it is the reality of the situation. Next, we have the cybersecurity. They're protecting your system from the hackers. You know, all the data is online, everything's connected, which means it's vulnerable. And every few months, we're seeing new breaches. You know, millions of dollars in damage. We just saw, I believe it was the British National Health System. They got malware on their machines, you know, ransomware, and it was shutting down emergency rooms. And, you know, as everything becomes more connected, I mean, people can literally die if the things aren't secure. So this is a very, very hot topic, is a very hot field. Cybersecurity is an arms race. So we're making better systems and upgrading software security, and the black hat hackers are out there breaking it. So then we make it better and they break it, and we make it better and they break it. And this is a continuous arms race. So by far, it's the fastest growing specialization, but I also, this branch of IT requires the most learning, continuous learning. You are going to be on the treadmill, and every quarter there is going to be new information. You will never stop. It is very fast, it's very intense if you want to stay current. Degrees are possible, but there's not many colleges that offer good degrees, because a college course with accreditation takes a long time to put together. And usually by the time they've put it together, there's a lot of topics in it that are out of date and obsolete. So it's very difficult for a college to offer a degree and maintain the relevance of that degree in cybersecurity. So what we see in cybersecurity is a lot of vendor certification and third-party training programs that are a little more nimble. So a couple you have, Certified Ethical Hacker, there's an EC Council that does that. And there's the ISC2, which offers a Certified Information Systems Security Professional, which is the CISP degree certification. So that's usually where you're at with cybersecurity. You're getting third-party training. You're typically not going to college. If you have a network administration background, or you're a little bit of a hardware junkie, that is definitely a better pathway into cybersecurity, because the networks are what you're protecting. Then we have their software developers, and they bring data to life. So this was my specialization for many years. You know, like I said before, software developers kind of take data out of the database, manipulate it, and put it back. So software developers are just making data more useful. and you're writing these instructions and transforming things into formats with rules and validation, and processing. And, software development, there are dozens and dozens of different languages. And, back when I was learning programming, in the 90s, it was easier because you generally only had to know one language to build an application. Those days are over. So if you want to be a web developer today, like in the Software Guild's .NET Bootcamp, you're going to learn HTML, CSS, C#, SQL. There's and JavaScript. So there's 5 different languages that you have to know if you want to be a full stack web developer. So, I always kind of encourage my students. It's interesting because learning to program is easier today because we have the internet and you can look things up. But it's harder because you have to know 5 different languages to build an application, where back in the day, I only had to know 1, maybe 2 to build an application. So it's easier and harder at the same time. And then within development, specialize. Do you want to be a front-end developer? Do you want to work mostly on the website? Do you want to make animations and user experience workflows and form fields and things like that? Do you want to write the middle tier where you have your services and your business rules? So, to kind of explain that, you go check out on Amazon.com. Your visual shopping cart is the front end. And then when you hit submit bill, or, if you want to check out, then there's a bunch of stuff in the background that starts running. It bills your credit card. It notifies the warehouse that, you have something that needs to be shipped. It sends you an email with shipping information. It has to store all that information in a database somewhere so that you can look up your order later. So all of those things are happening in the middle and the back end. And as a developer, if you work for a smaller company, you might have to be what we call a full stack developer, where you have to go front end all the way to the back end and you have to know everything. And that's what we teach at the Guild. But in the field, you go work for a bigger company, they will have a front end team, and they'll have a services team, and they'll have a database team. So you might actually only work on one part of the stack. So it's more of, depending on where you work, you're going to go wide or you're going to go deep. So you want to be a software developer? There are many, many pathways to get into this. So you could be completely self-taught. You can also get a degree at a university, information systems, computer science. If you are interested in more engineering type programming, like if you want to build the next Windows operating system, you want to do artificial intelligence, you want to build interfaces for robotics, computer science is definitely for you. Those roles, like if you want a job at Microsoft Research or Google, computer science program is still the best way to get there. If you want to work on business applications, so you want to go work for an insurance company or a bank or any of the number of startups like Fitbit, or you want to go work for Nike on their warehousing system. In those kind of business systems, you can generally self-teach, get vendor certifications, go to a boot camp. You can get a college degree. It's not wrong to do that. So web development and business application development, they're very accessible. There's a lot of demand, so most companies do not care where your skills come from as long as you have those skills. And then lastly, we have the data scientists. They're focused on those analytics. So they're mining data and looking for insights to boost revenue. So, this is very hard to get into because they're a mixture of mathematician, software developer, and trend spotter. So a lot of people ask me, hey, do I have to be really good at math to be in IT? And I usually say, well, if you're a network administrator, database administrator, cybersecurity, and most software development, no. If you can do Algebra 1, Algebra 2, you're probably fine. As soon as you say data scientist, now you need to know calculus and statistics if you're going to be successful. So also this field is kind of new, and from company to company, different companies want different things. So the most important thing is just a high level of aptitude for math and statistics. They usually begin life as a statistician or a data analyst. And you do see some software developers and DBAs moving into this role. But that's more because of the high salaries and demand for these data scientists. We're seeing a lot of IT people that have the aptitude being pulled into this role because the money's really good. And honestly, if you learn the tool sets, it's really cool stuff. So their day-to-day job is grabbing heaps of data and then figuring out how to draw conclusions from that data. So, you know, I always tell people, imagine if somebody just came in with a big filing cabinet and they dumped all the papers on your desk in a big heap, and they said, tell me what you can learn from all this data. And that's kind of what data scientists do. So, you know, they end up dabbling in machine learning because machine learning and AI, it's much more efficient if you can have a machine teach itself how to go through that pile of data rather than having to explicitly program it. So it's a newer field. It's very interesting. If you're a math geek, it's highly rewarding. And then we have the architects. This is what I used to do before I started the guild. So you're basically setting that technical vision for the solution. You usually have a problem and you have a whole pile of resources. You have your network administrators, software developers, and all those people. And you say, how can I configure all of these resources into a solution that solves this problem? And it's always cross-discipline because you have to be able to talk to all the different specialists in IT. And then you also have to work with the business. You're usually in a lot of meetings with business people, talking to them about their problems. You have to be aware of the budgets. You have to be able to match the resources you have with the problem and what's possible within the budget. So there is definitely a soft skills side to being an architect as well. There's a lot of communication. There are some politics in being an architect because you got to get all these teams working together. But in smaller companies, there will be architects that usually do some development. They're usually software developers, and they will do some programming themselves. But a lot of time, architects don't do any implementation themselves. So, you know, the architect who designed my house, he doesn't come in and do the carpentry or the plumbing or the electrician work. He has an awareness of how all that works and how it all needs to come together, but he's not the one actually doing the work. You don't become an architect in college. Nobody on this planet will ever give a fresh college grad an architect position. This is something you learn through experience. So no degree, there's no real good certifications or anything out there. All it requires is that you have an IT career and you have done a lot of stuff and you have shown that you can see that big picture and you can pull all those things together. And from my experience, you know, I tell my students that graduate out of the software development program, if I graduate 100 students, maybe 3 of them will become an architect. It is not easy to do. Most people just don't have the aptitude to juggle that many moving parts and have that kind of breadth of knowledge that it takes to become a good architect. So, you know, up in Northeast Ohio, where I am near Cleveland, I mean, I can count the number of good architects on one hand. I mean, it's not very common to become one and then be a good one. Like I mentioned before, it does require a lot of soft skills. So you're the liaison, you're negotiating, you're handling budgets, you're managing risks, you're creating plans, you're presenting plans for approval, you know, and the buck kind of stops with you. So just to kind of summarize everything I went over here, where do you start? You'll notice that, you know, most of the pathways in IT, there's a couple different starting points. There are boot camps for most programs. There's degrees for most programs, and there's vendor certifications for almost everything. The only one that you can't really get a start in is architect, because that requires experience. So let's talk a little bit about these different starting points and why you might choose one over the other. So we'll start with higher ed. Everybody's familiar with higher ed. The pros is that it is accredited. I mean, a college degree has meaning, and a college degree is valuable in your career. Even though you don't need one to get started in most of the fields, if you have one, you will make more money quicker. The problem is to get that degree takes a lot more time and it's generally more expensive. So there is an opportunity cost for doing that. You can also get your FAFSA student loans through the college, so there's cheap loans available. And a degree program makes you learn things outside of your specialization. So, you know, you're going to get some language arts and some liberal arts, and as well as your core job skills in an employer program. And they're still weighted very highly by employers. So if you have two students or two people applying for a job, and all other things being equal, one has a degree, one doesn't, they're probably going to hire the person with the degree. So the cons, time requirement's a big one. It takes 4 years to get a bachelor's degree. That's also very expensive. And if you're just looking at job skills, then some people think that general education is a waste of time. I don't necessarily believe that, because if you look back at the architecture role and things like that, all those soft skills, communication, you know, negotiation, budget management, I mean, those are broad skills, and you will get into leadership a lot easier if you have a strong general education background. Now, if all you want to do is sit in the corner and write code, then the general education isn't really doing much for you in that case. But the biggest con probably with higher education is that they are very slow to adapt new content. So you go to a programming class at a university, they're generally not teaching the framework that just came out last month. They are teaching the framework that came out a year ago. It takes them a long time to get curriculum, get it accredited, get it approved, find an instructor. So that turnaround time is very difficult for higher education. So then you have your boot camps, very fast paced, very specialized, very current. The boot camp is basically a response to higher education's cons. They're very hyper focused on careers and job placement, where colleges, they have departments to get you jobs, but it's way more intensive and way more hands-on generally in the boot camp world. But then, you know, with every pro, there's a con. They're non-accredited. Most boot camps, there is no accrediting body, which means that you're kind of at their mercy for their marketing. They're not eligible for FAFSA student loans, so you can get loans for a boot camp, but usually at a higher price than getting a college loan. It's also not tax deductible, unlike an education loan from a college. And then because these boot camps are not well regulated, there's a lot of variance in quality. I can tell you as a boot camp founder that the barrier to entry for starting a boot camp is very low, and there have already been quite a few programs that have started up and closed within a year because they were basically just ripping people off and not doing a good job. So that variance is a big risk for students in the boot camp pool. Your vendor certifications, the main thing is that it's vendor certified. So if you want to work on Microsoft hardware, if you want to work on Oracle hardware, then getting the Microsoft or Oracle certification is meaningful because it's written by the vendor. They also tend to be very fast paced. Most of your certification programs to train for a test takes about 5 days. The big con for that is that it only takes 5 days. So you don't really get real world experience. Most of these vendor certifications are multiple choice tests. And I can tell you, I have never sat down at my computer to write a program and have it give me multiple choice questions to write my code. So you can literally study for the test and pass the test and have a vendor certification and not know what you're doing. Those vendor certifications also generally do not have job placement services, and they also generally lack financing. So, and then of course you can teach yourself, and that's free or very cheap if all you do is buy a couple books. This is probably the most common question I got as a bootcamp founder. People will say, well, why should I pay for a bootcamp if I can teach myself to code for free? And I always respond to that and I say, well, you can only teach yourself for free if your time is worth 0. Because to go through and learn everything that you would learn in a bootcamp program or even in a college program, because you could go buy all the books, you know, for a degree at Oregon State if you wanted to and just read them. But the time it would take you to go through that, and you're not getting any support, so nobody's checking your work, nobody's answering your questions, and nobody's helping you get a job. So by the time you go through that and you find all the answers you need and you actually learn what you need to do, it is going to take you significantly longer. So I always break it out for people. You know, our bootcamp program is about 800 hours. So if you were going to do that completely on your own, conservatively, it would probably take you 2,000 to 3,000 hours to go through that. A full-time job is 2,000 hours. So, you know, you're talking more than a year, probably almost 2 years to self-teach yourself to the same level that we are. So if you can get out of the program and start making $60,000 a year, the opportunity cost of self-taught is $120,000. So will you spend 120 to save 13? Okay, I mean, if that's what you want to do, go ahead and do that. But self-taught is a very difficult road. That's the biggest con. No support, takes a long time, and you're not going to get any job placement assistance. So we're partnered here at the Guild. This is my pitch now. So we're partnered with Oregon State University, and the Software Guild happens to be one of the top programs in the world. And we know this because we are a founding member of CIRR, so CIRR.org. I want you to go to that website. They have outcomes on there. These outcomes are audited by independent auditors, and they have standards for reporting outcomes. As I mentioned before, a big downside of boot camps is that there's no regulation. CIRR is the first attempt at some regulation and, you know, transparency and outcome reporting. So what you can do on CIRR is any boot camp that's a member of CIRR, you can click on their statistics and you can see how many people started, how many people graduated, how many of them got jobs, how long it took them to get the jobs, what they got paid, what their job titles were. You know, and not even any colleges do this. So we're giving like more information than a college gives, you know, about their graduates. So this is a big deal. And we're pleased to be a founding member of that. All the Guild instructors are full-time, they're experienced. You know, that's a big difference from us. You will not have, you know, a TA that's in their master's degree teaching your class. We only hire people that have actually worked in the field, because a big part of your learning experience is not only learning to code, but learning why you want to do things a certain way. And all of our instructors have lots of stories about, well, here's something we ran into on the job, and here's the problem when that occurred, and here's what we did about it, and here's what we learned. And you can kind of pick up that knowledge, you know, in that master apprentice type model. The Guild also is one of the only programs in the world that has learning science embedded into it. We actually have a curriculum development team and learning coaches, and all these people do is study learning science. And then they work with our instructors and our curriculum development staff to apply that learning science to our curriculum instruction so that you can learn better and more efficiently. And we have been running for about 5 years, and we've graduated hundreds of graduates. So, you know, unlike some of the newer boot camps that have started iterating this curriculum, we change it every 6 months. You know, we basically teach something, we measure the outcomes, we observe, and then we improve. And we've been doing that for 5 years. So our curriculum is awesome. And then the other thing is there's 2 types of boot camps. There's ones that will take anybody who can write a check, and then there's ones that have selective admissions. And we have selective admissions. So if you're looking at going through a Guild program, we actually have a free course online, and you go take that course, and when you're done, you set up a virtual meeting with one of our staff. and we're going to do a paired programming exercise with you, and we're going to test you on your understanding of what you learned in that free course. And what we've learned over time is that if you learned the things that we wanted you to learn, and you can demonstrate that competency from the free course, you have a very high probability of being able to pass our program. We have a 92% graduation rate. The graduation rate in computer science is less than 50%. Again, to get into computer science, all you need to do is have a good enough GPA, and they'll take your money. At the Guild, we want to see that you have some programming aptitude. So we don't want to take anybody's money if we don't think that they have a high chance of succeeding. So 92% graduation rate. Be very careful if you're looking at boot camps and they don't have a selective admissions process. That's really all I have. So let's see if there's any questions. And maybe my Patreon.
Yeah, Eric, it looks like we have a few questions that have come in. Thank you so much. That was great. So 1 second.
Okay.
All right. So, and I have some information here about how to get started with our Coding Certificate Bootcamp. So the application deadline for the next course that starts on August 7th is July 31st. And that was the one that Eric was just talking about. So feel free to reach out to me if you guys have any questions about enrolling or how that all works. So Eric, what is the biggest mistake people make when they're exploring this field or getting started in this kind of job market?
The biggest mistake I see people making is lack of focus. So what I'll see what I'll hear anyway, and what I've observed is that somebody will say, well, I want to be a programmer. Oh, okay, good. You want to be a programmer. Okay, I'm going to start learning Python. And they go and they start learning Python for a couple weeks. And then they say, oh, well, this JavaScript thing looks really cool. I'm going to go learn JavaScript. And they start learning that. And then something else shiny happens. And then they switch, and then they switch, and then they switch. And basically what happens is they just learn the 3 weeks of programming across 12 different languages, but they're still only a 3-week programmer. So, you know, I usually encourage people, if you want to learn to program, pick a language and go deep. Go as deep as you can. Because what you'll find is as you master certain techniques, those techniques apply to other languages too. So stay focused and stick with one thing. And that's actually, you know, in the curriculum at the Guild, the first 4 modules are just Java fundamentals, are just C# fundamentals. And we go deep into object-oriented programming. And then what we've seen is when our students graduate the program, we have students that graduate in Java or C# and they go get a job doing Ruby, or they go get a job doing Python. And they always come back and they're like, yeah, you know, you guys really made us go deep in the one language. And when I got over to Ruby or Python, I saw the same concepts. It's just the language syntax was a little different, but it was the same concepts. And I was able to learn that language in 5 weeks. And it's like, yeah, that's the really important thing. So don't bounce around. Don't be shallow. Go deep in whatever you're trying to learn.
Awesome, thank you. And you talked about a lot of different fields and a lot of different applications in the job market. Which of those do you think has the most growth?
Cybersecurity right now.
For sure.
Yeah, so if you're looking at the next 24 months, cybersecurity is probably going to be at the top, and then web development and data science are probably the next 2.
Yeah. So, and if somebody
I don't think there's a bad choice in IT right now, to be honest, though.
Okay. It's probably a pretty solid field, you're right. Yeah. So after somebody goes through your boot camp, it's pretty intensive, but what's the job placement after somebody goes through and completes the coding boot camp?
For us, it typically ranges somewhere between 85 and 95%. Our most recent SIR report, it landed at 88%. So
wow, that's awesome.
It depends cohort to cohort. So I mean, sometimes, you know, just the law of averages, you'll get a batch set. you know, a couple students are weaker, and then you end up, you know, in the 80s, and then sometimes you'll get 95. And I had a class 18 months ago that was 100% placement. You know, it just kind of bounces around.
That makes sense. Well, thank you so much. And again, everybody, professional continuing education is the non-credit arm of Oregon State University. Happy to answer any questions that you guys may have about the boot camp and the Software Guild. You can visit our website for the application information and connecting with the Software Guild about this course. Eric, do you have any last messages or?
No, I mean, good luck. And, you know, the main thing, no matter which branch of IT you go in, is passion. Because like I said, it's lifelong learning. So if you don't like computers, don't go into the field for the money, because you're going to be miserable, because you have to like this stuff. You have to like learning, or it's just not going to work out for you.
Yeah, I like that. That's a good message. All right, thank you everybody so much for joining us. And again, you'll get a copy of this recording out within the next 24 hours. Thank you so much, Eric.
Yep, thank you.
Bye.